NASA just revealed something that changes everything. After weeks of silence, after institutional delays and mounting pressure from the scientific community, they've finally shown us the first signal that Atlas sent toward Earth. And what we're seeing in this data is forcing scientists to ask questions they never thought they'd have to ask. Questions about what Atlas really is. Questions about where it came from. And most importantly, questions about what it wants. This is not speculation. This is not conspiracy theory. This is real observational data confirmed by multiple independent sources. Today is November 10th, 2025, and the investigation into 3I Atlas has just entered a completely new phase. What started as curiosity about an unusual interstellar visitor has become something far more profound, far more unsettling, and potentially far more significant for humanity's future. Let me be absolutely clear about what we're dealing with. The researcher known as Avi Loeb, one of the most respected astrophysicists in the world, and the former chair of Harvard's astronomy department, has just published updates that fundamentally shift the tone of the entire Atlas investigation. The data he's highlighting isn't ambiguous. It isn't open to multiple easy interpretations. It's concrete, measurable, and deeply troubling for anyone who wants to maintain that Atlas is just a natural comet passing through our solar system. The two most significant pieces of evidence are these. First, we have the first confirmed radio detection of Atlas, achieved by the Meerkat Radio Telescope Array in South Africa. This isn't just picking up reflected signals or background noise. This is detecting specific absorption signals linked to hydroxyl molecules, chemical markers that tell us Atlas is thermally active, releasing material as it interacts with radiation from our Sun. Second, we have new images from November 8th, 2025, that reveal something absolutely extraordinary. A complex network of at least 7 distinct jets emerging from Atlas after its closest approach to the Sun, its perihelion passage. Now, you might be thinking, jets from a comet aren't unusual. Comets release gas and dust all the time as they're heated by the Sun. That's what creates their tails, their visible activity. But here's the problem. These jets aren't behaving like normal comet jets. Several of them are pointing toward the Sun, not away from it. They're what astronomers call anti-tails or sunward jets. And while they can occur naturally under specific conditions, the pattern we're seeing on Atlas, the complexity, the number, the distribution, is making scientists extremely uncomfortable. Avi Loeb, being the careful scientist that he is, presents two possible explanations for what we're observing. The natural explanation suggests these could be pockets of ice on a conventional comet nucleus, each emitting gas and dust when heated by solar radiation. The technological explanation, and yes, this is being seriously discussed by mainstream scientists now, suggests these could be attitude control thrusters or propulsion systems, intentional jetting that would indicate we're looking at a spacecraft, not a comet. And Loeb's position on this is crystal clear. He's not claiming one explanation over the other. He's insisting that both hypotheses must remain on the table while we gather more data. He's calling for transparency, for access to higher resolution images, for the kind of rigorous scientific investigation that this unprecedented situation demands. But here's where the story gets frustrating, and frankly, a bit disturbing. NASA has high-resolution images of Atlas. The high-rise camera aboard the Mars Reconnaissance Orbiter captured detailed photographs of Atlas on October 23, 2025, when the object passed relatively close to Mars. These images could offer approximately 30 meter per pixel resolution, a massive improvement over ground-based observations, and even better than what the Hubble Space Telescope can achieve for an object at Atlas's distance. These images exist. They've been taken. They're sitting in NASA's archives, and they haven't been released. According to Avi Loeb, formal scientific requests for this data have been submitted. Letters from congressional representatives have been sent. The astronomical community has been pressing for access to these crucial images. And yet, NASA's response has been slower than continental drift. Loeb has publicly criticized what he calls a double standard, noting that high-profile figures seem to get faster responses than the scientific community conducting actual research. He emphasizes that this data is time-sensitive, that it could shape coordinated observations in the coming weeks, and that withholding it impedes the rapid scientific work that this extraordinary situation demands. So why the delay? Why would NASA sit on data that could help us understand what might be the most significant astronomical discovery in human history? There are several possible explanations, and none of them are particularly comforting. The most innocent explanation is simple bureaucracy. NASA is a massive organization with complex data release protocols, and sometimes things just move slowly. But given the significance of what we're dealing with, that explanation feels inadequate. A more concerning possibility is that NASA has seen something in those high-resolution images that they're not ready to share with the public. Something that would raise more questions than it answers. Something that might cause panic or confusion, or that might require careful coordination with other government agencies before release. And the most troubling possibility, the one that keeps conspiracy theorists up at night, but that even serious scientists are starting to whisper about, is that those images show clear evidence of artificial structure, of technology, of something that cannot be explained away as natural phenomena. But let's get back to the concrete evidence we do have access to, because it's extraordinary enough without speculation. The Meerkat radio telescope observations are particularly significant. Meerkat is one of the most advanced radio telescope arrays in the world, located in South Africa, and it's designed specifically to detect faint radio signals from cosmic sources. When Meerkat observed Atlas in late October, it detected absorption signals at specific frequencies associated with hydroxyl molecules. Now, let me explain why this matters. Absorption signals occur when cold gas is positioned between the telescope and a warmer radiation source in the background. The molecules in that gas absorb specific frequencies of radio waves, creating dark lines in the spectrum. What Meerkat detected tells us that Atlas has a cloud of cold gas around it, gas that's being released from the object's surface or interior. The width and shape of these absorption signals correspond exactly to what we would expect if the object's surface were at a specific temperature, consistent with the distance Atlas was from the Sun at the moment of observation. Avi Loeb analyzed the velocity data as well. When you factor in Atlas's total speed relative to Earth and the angle between its motion and the telescope's observation direction, the Doppler shift in the detected signals matches perfectly with what you'd expect from an object moving at those speeds. In simple terms, the radio detection is real, it's consistent with physical laws, and it confirms that Atlas is releasing molecular material into space. But here's the critical question that this raises. Is this outgassing consistent with a natural comet, or is it evidence of something else? To answer that, we need to look at another piece of the puzzle, the acceleration anomaly. Interferometric observations, incredibly precise measurements of Atlas's position over time, show that the object is not following the trajectory that pure gravitational forces would predict. Its actual path deviates from the calculated orbit. This means there's a non-gravitational force acting on Atlas, accelerating it in ways that gravity alone cannot explain. For a normal comet, this isn't surprising. As ice sublimates, turning directly from solid to gas. It creates jets of material shooting off the comet's surface. These jets act like tiny rocket engines, pushing the comet slightly off its predicted path. This is called the rocket effect, and it's been observed on many comets. So, problem solved, right? Atlas is just experiencing the rocket effect, like any other comet. Except there's a massive problem with this explanation. The laws of physics, specifically the conservation of momentum, tell us exactly how much mass a comet would need to lose to produce a given amount of acceleration. When scientists calculated how much material Atlas would need to eject to explain the observed deviation in its orbit, they got a shocking answer. Atlas would need to lose approximately 1/16 of its total mass. That's roughly 15% of the object, or about 5 billion tons of material. Think about that for a moment. 5 billion tons of gas and dust ejected into space. That's not a subtle effect. That's not something you could miss. If Atlas had released that much material, it would create an enormous, bright, easily detectable debris cloud. Dozens, hundreds of observatories around the world would see it. It would be one of the most active comets in recent history, visible and obvious. But here's the thing. That massive debris cloud hasn't been clearly observed. It's not there. Or at least, it's not there at the scale the calculations require. This leaves scientists in an extremely uncomfortable position. There are only two possible explanations. Either there exists some unknown natural mechanism that can produce acceleration without the expected mass loss, some exotic physics we don't yet understand. Or Atlas has some form of propulsion system that generates thrust without ejecting enormous amounts of material. A propulsion system, technology, artificial control. Avi Loeb is careful to state that this doesn't prove Atlas is artificial, but it does mean we cannot rule out that possibility based on current evidence. And that's a profound statement, coming from a mainstream scientist at the top of his field. We're at a point where the technological hypothesis, the idea that Atlas might be a probe or spacecraft from another civilization, must be kept on the table as a serious scientific possibility while we gather more data. Now let's talk about those images from November 8th. These were assembled from 24 green filter frames, each 35 seconds of exposure time, plus additional red and blue frames. The observers who captured these images were working under difficult conditions. Bright moonlight, twilight, far from ideal. But the features they captured are persistent, appearing across multiple frames, which strengthens the case that they're real physical structures, not artifacts or errors. What do the images show? A large, persistent halo extending to roughly 500,000 kilometers from Atlas, and within that halo, at least 7 distinct jets. Several of these jets are pointing toward the sun, sunward jets that are unusual for comets. The standard comet model has jets pointing primarily away from the sun as heated ice sublimates and is blown back by solar wind and radiation pressure. Sunward jets can occur, but they require specific conditions and orientations. To have multiple sunward jets, along with jets pointing in other directions, creates a pattern that's hard to explain with simple heating and sublimation. Avi Loeb points out that if these are natural, they could represent multiple active regions on the surface, pockets of ice at different locations on a rotating nucleus, each becoming active as it rotates into sunlight. But he also notes that if you were designing a spacecraft with attitude control thrusters, with small engines used to adjust orientation and trajectory, this is exactly what it might look like. Multiple jets at different angles, capable of firing in different directions to produce the desired changes in motion. The fact that both explanations are plausible, that we genuinely cannot distinguish between them with current data, is what makes this situation so extraordinary. We're looking at an object from outside our solar system, an object that's behaving in ways that are consistent with both natural phenomena and artificial technology. And we don't have enough information to definitively choose between those possibilities. But there's more to this story. The direction Atlas came from is itself intriguing. When astronomers traced back its trajectory, projecting where it came from before entering our solar system, they found that its incoming direction lies within 9 degrees of the famous WOW signal from 1977. Now, for those unfamiliar, the WOW signal was a strong, narrow band radio signal detected by a radio telescope in Ohio. It lasted 72 seconds, bore the hallmarks of an artificial transmission, and has never been detected again or adequately explained by natural sources. The connection between Atlas and the WOW signal might be pure coincidence. Space is vast, and 9 degrees is not an insignificant angle, but it's close enough that it can't be entirely dismissed. Is it possible that Atlas came from the same region of space that produced the WOW signal nearly 50 years ago? Could both be connected to the same source, the same civilization, if indeed either represents something artificial? These are questions we can't answer yet, but they're questions worth asking. Looking forward, there are several crucial opportunities coming up to gather more data on Atlas. One of the most significant is in March 2026, when Atlas is predicted to pass approximately 53 million kilometers from Jupiter. NASA's Juno spacecraft is currently orbiting Jupiter, conducting detailed studies of the planet's atmosphere, magnetosphere, and interior structure. But Juno also has a dipole antenna, capable of detecting radio signals at low frequencies, from 50 Hz to 40 MHz. Avi Loeb has advocated for using Juno to monitor Atlas during this relatively close passage. The idea is to scan for any coherent radio emissions, any signals that might indicate artificial activity. If Atlas is transmitting, if it's communicating or broadcasting in any way, Juno might be able to detect it. This is a unique opportunity, because Juno will be much closer to Atlas than Earth-based telescopes, potentially able to pick up faint signals that would be undetectable from our planet. The Meerkat hydroxyl detection proves there's molecular material around Atlas to study with radio telescopes. The next step is checking for coherent emissions, structured signals that can't be explained by natural processes. Multiple radio telescope networks around the world are being urged to keep monitoring Atlas continuously, especially as it emerges from solar conjunction and becomes more easily observable again. As of now, over 200 observatories are tracking Atlas, with hundreds more expected to join the effort as viewing conditions improve. This represents one of the largest coordinated astronomical observation campaigns in history. Scientists from dozens of countries are sharing data, comparing notes, analyzing every piece of information they can gather about this mysterious visitor. The level of international cooperation is remarkable, driven by the recognition that understanding Atlas is crucial, not just for astronomy, but potentially for humanity's understanding of our place in the universe. Let me summarize what we know with certainty. Atlas exhibits confirmed radio absorption at specific frequencies, detected in late October with well-measured Doppler shifts. This is the first confirmed radio detection of the object. It displays a complex jet network, with recent images revealing at least 7 jets and a halo of approximately 500,000 kilometers, including sunward-directed jets that are highly unusual for comets. It shows non-gravitational acceleration, with orbital models confirming acceleration terms that cannot be explained by gravity alone. Importantly, no measurable acceleration has been detected outside the orbital plane, which is itself an interesting constraint on whatever mechanism is causing the observed acceleration. there's a massive question about mass loss. To explain the observed acceleration through normal outgassing, Atlas would need to lose approximately 1/16 of its mass, roughly 15%, or about 5 billion tons. But no corresponding massive debris cloud has been clearly observed at the scale required. Atlas exhibits unique photometric behavior, including rapid brightening and a blue shift near perihelion that differs from standard comet behavior. Its origin trajectory is notable, arriving from within 9 degrees of the famous WOW signal direction from 1977. And we're awaiting critical high-resolution data, specifically images taken in early October, that could potentially resolve many of these mysteries, but remain unreleased. There's also the Jupiter observation opportunity coming in March 2026, when Juno could potentially detect radio transmissions if Atlas is broadcasting. And we have coordinated global monitoring on an unprecedented scale, with the astronomical community mobilized like never before to track and study this object. So where does this leave us? We have new and measurable observational signals, hydroxyl radio detection, jet network structure, non-gravitational acceleration. And simultaneously, we have critical data, gaps, withheld high-rise images from NASA, need for coordinated radio surveillance, and unanswered questions about the mass loss problem. Avi Loeb's position is clear and scientifically sound. If mass loss is confirmed at the scale the calculations require, then Atlas will be classified as an extraordinarily active comet, one of the most active we've ever observed. But if that debris cloud doesn't appear, if we can't account for the missing mass, then we're left with an uncomfortable question. What force caused the acceleration without the corresponding mass ejection? And that question opens the door to possibilities that most scientists are extremely reluctant to publicly embrace. The technological hypothesis remains on the table, not because scientists want to jump to extraordinary conclusions, but because the evidence is refusing to fit neatly into natural explanations. We're dealing with an object that shows signs of activity, of acceleration, of complex structural features, but without the expected consequences of those activities. It's like watching an airplane fly without seeing any jet exhaust or hearing any engines. You know something is producing thrust, but you can't identify the mechanism. What happens next is crucial. The coming weeks and months will bring new observations as Atlas emerges from solar conjunction and becomes more easily visible again. Radio telescopes will continue monitoring for any signs of artificial signals. Observatories will track the acceleration, watching for changes that might provide clues about its cause. And hopefully, eventually, NASA will release those high-resolution images that could answer so many questions. But regardless of what we discover, one thing is already clear. Atlas has forced the scientific community to grapple with possibilities that were once relegated to science fiction. The idea that an interstellar visitor might be artificial, that we might be observing technology from another civilization, is no longer something you can dismiss out of hand. It's a hypothesis that must be seriously considered, tested against evidence, treated with the same rigor as any other scientific proposal. Avi Loeb has been careful not to claim proof of anything extraordinary. He's not saying Atlas is definitely artificial. He's saying we don't know, and that we need to keep all possibilities open while gathering more data. That's how good science works. You follow the evidence wherever it leads, even if it leads to uncomfortable places, even if it challenges your assumptions about reality. The first signal that Atlas sent toward Earth, those hydroxyl absorption lines detected by Meerkat, might seem mundane on the surface, just molecules being released by a heated object. But combined with everything else we're seeing, the acceleration without mass loss, the complex jet patterns, the unusual photometric behavior, the institutional reluctance to release detailed images, those signals take on a deeper significance. We're watching something unfold in real time. An investigation that started with curiosity about an unusual visitor and has evolved into something that might reshape humanity's understanding of whether we're alone in the universe. The evidence isn't definitive yet. We don't have proof of extraterrestrial technology, but we have anomalies, mysteries, observations that don't fit comfortable explanations. And sometimes, that's how the biggest discoveries begin. Not with a clear answer, but with questions that refuse to go away, with data that doesn't match expectations, with the courage to consider possibilities that seem impossible until they're proven true. Atlas is still out there, moving through our solar system, releasing its mysterious signals, displaying its enigmatic behaviors. Scientists are watching, measuring, analyzing, arguing about interpretations. And somewhere in the data we're collecting, in the signals we're detecting, in the images we're capturing, might be the answer to one of humanity's oldest questions. Are we alone? Atlas might not give us that answer definitively, but it's already shown us that the universe is stranger, more mysterious, and potentially more populated than we ever imagined. And that realization, regardless of what Atlas ultimately proves to be, changes everything. Let me dive deeper into the technical details, because understanding the specifics is crucial to appreciating just how extraordinary this situation really is. The hydroxyl absorption signals detected by MeerKAT weren't just random noise that scientists are interpreting generously. These were clear, specific spectral features at frequencies that correspond exactly to the rotational transitions of hydroxyl molecules. When molecules rotate, they absorb and emit radiation at very specific frequencies determined by quantum mechanics. These frequencies are like fingerprints, unique identifiers that tell us exactly what molecule we're looking at. The hydroxyl radical, OH, is particularly interesting because it's a breakdown product of water ice. When water molecules are exposed to ultraviolet radiation from the sun, they can break apart into hydrogen and hydroxyl. So detecting hydroxyl around Atlas tells us that water-based ice is likely present and is being processed by solar radiation. This is exactly what you'd expect from a comet, which is why the detection initially seemed to support the natural explanation. But here's where it gets interesting. The amount of hydroxyl detected, the distribution of the gas cloud, and the temperature indicated by the spectral line width all need to be consistent with each other and with the object's distance from the sun. When Avi Loeb and his team analyzed these parameters, everything checked out mathematically. The observations were internally consistent, but when they tried to reconcile the amount of outgassing indicated by the hydroxyl detection with the amount of mass loss required to explain the orbital acceleration, that's when the problems appeared. The rocket effect from outgassing should produce acceleration that's directly related to the amount of mass being ejected and the velocity at which it's ejected. It's basic physics, Newton's third law. For every action, there's an equal and opposite reaction. If you're throwing mass in one direction, you'll be pushed in the opposite direction. The stronger the push you want, the more mass you need to throw, or the faster you need to throw it. For Atlas, the observed acceleration requires an enormous amount of mass to be ejected at high velocity. But the hydroxyl detection, while confirming that outgassing is occurring, doesn't indicate the massive scale of activity that would be necessary. This discrepancy is what's keeping astronomers up at night. It's like seeing someone jump 10 feet in the air, but not seeing the trampoline or rocket pack that would make such a jump possible. Something doesn't add up, and until we figure out what's missing from our understanding, we can't rule out any explanations, including extraordinary ones. The jet patterns revealed in the November 8 images add another layer of complexity. When a normal comet develops jets, they typically form in specific patterns related to how the nucleus is rotating and where the active ice deposits are located. As the comet rotates, different areas move into and out of sunlight, activating and deactivating like a rotating garden sprinkler. This produces jets that sweep across the sky in predictable patterns. But Atlas's jets don't quite fit this simple model. The presence of multiple sunward jets is particularly puzzling. For a jet to point toward the sun, you need either a very specific geometry, where a vent on the nucleus happens to be oriented that way, or you need some kind of active process that's deliberately directing material toward the sun, rather than letting it be blown away by radiation pressure. Neither explanation is impossible, but having multiple such jets suggests something more complex than the standard rotating iceball model. If we entertain the technological hypothesis for a moment, what would those jets represent? The most obvious interpretation would be attitude control thrusters, small rockets used to adjust the orientation and trajectory of a spacecraft. Modern spacecraft use such systems routinely. The International Space Station, for example, periodically fires thrusters to maintain its orbit and orientation. A probe traveling between star systems would almost certainly need similar capabilities to make course corrections, to adjust its trajectory as it passes through a solar system, to orient itself for observations or communications. The pattern of jets on Atlas, with multiple engines firing in different directions, would be consistent with a system designed for three-axis attitude control, capable of rotating and moving the object in any direction needed. But again, this is interpretation, not proof. The same visual appearance could potentially result from a natural object with a complex distribution of volatile ices and an irregular rotation. This ambiguity, this inability to definitively distinguish between natural and artificial explanations based on current data, is exactly why the high-resolution images from Mars Reconnaissance Orbiter are so critical. With 30 meter per pixel resolution, those images could potentially show surface details, textures, structures that would make the distinction clear. If Atlas is a natural object, even a highly unusual one, it should show the rough, irregular, chaotic surface texture, typical of comets and asteroids. Random impact craters, irregular shapes, surface features that clearly result from natural accretion and evolution. But if Atlas is artificial, if it's a manufactured object, there might be signs of that in the surface appearance. Regular patterns, geometric shapes, smooth panels, seams, or joints where components connect. The difference between a boulder and a building is obvious when you can see enough detail. The Mars Reconnaissance Orbiter images should have enough resolution to make that distinction, which is exactly why their continued non-release is so frustrating to the research community. There are legitimate reasons why data release might be delayed. Calibration takes time. Analysis requires resources. NASA has protocols for how and when data is made public. But given the extraordinary nature of Atlas, given the global interest in understanding this object, given that the images are now more than 2 weeks old, the delay is starting to look less like standard procedure and more like deliberate withholding. And that naturally raises questions about what those images might show. Another aspect of the Atlas mystery that deserves deeper examination is its photometric behavior. This is one of the key mysteries that the coming months of observation will hopefully resolve. Atlas is still out there, still moving through our solar system, still broadcasting its enigmatic signals. Scientists worldwide continue their unprecedented coordinated effort to understand this visitor. And somewhere in the data being collected, in the signals being detected, might lie the answer to whether we're truly alone in the universe. The first signal has been received. Now we wait to see what Atlas will reveal next.